This is a B7 ecology video looking at decomposition, so it's triple content, and we're looking at anaerobic decomposition. And first of all, to introduce ourselves to that, we're going to talk about what is a biogas. Okay, biogas is mainly methane, some carbon dioxide, traces of hydrogen, nitrogen and hydrogen sulfide. Important thing to know is that we make biogas to get the methane, okay, and that's what comes out of the gas taps in the lab. And it's produced by anaerobic fermentation of organic waste containing carbohydrates by bacteria. So organic waste and bacteria. And the organic waste can be from sewage, it can be from grass cuttings, food waste, anything that can decompose. And it's anaerobic, okay? It's in the absence of oxygen. Okay, so here is the anaerobic digester. Okay, and what we've got on the left hand side is where we put in all of the organic waste. We've got like a floating capsule here that can rise as the gas is being produced, a tap to remove the gas, and then this is where we remove the waste product, the slurry, which later becomes fertiliser. So we can see here organic materials such as dead plants, animals and bacteria all get fed in as organic waste. Okay, so it could be any kind of anything that could decompose, sewage, materials left over from factories that are have got organic waste as a waste product, and it feeds into this anaerobic digester, and bacteria break it down. Okay, so we can see here this is where the biogas is going to be formed. And we've got this floating gas holder, so as the volume of biogas increases, that floats up and gives an indication to the people using the anaerobic digester of when they need to open that tap to release some of the biogas. And as a result of it, as well as the biogas, we get this digested slurry, and that is what we then use as a fertiliser. Okay, so this is a continuous process. That means we are continually adding in the organic waste, continually removing the biogas and the digested slurry. Okay, when we looked at the production of mycoprotein, the corn meat substitute, we were looking at a batch process which worked for about 6 weeks, and it was aerobic. This is anaerobic, and it's a continuous process. So we're constantly feeding in, constantly getting the product out. And when we look at the conditions that help it work efficiently, temperature is really important. So it's in the ground, you can see it's insulated there. There's a heater in there as well, so in colder conditions of winter or in colder climates, the temperature can be controlled for maximum production, maximum efficiency of that biogas. And as I said already, it's a continuous flow method. Okay, so it involves adding organic material constantly, removing the biogas constantly, and the digested slurry. So it doesn't need to be cleaned out, it just keeps on getting reused constantly, so we're constantly getting the products. Now, I've seen a graph before on this, and it talks about the first 5 days, saying that in the first 5 days there was actually carbon dioxide produced, and then it faded off, and in that first 5 days then the methane concentration started to increase. And the question was, why is there carbon dioxide in the first 5 days of setting it up? And the reason is that it's when we first set it up, we can't remove the oxygen. Okay, so it's not actually an anaerobic decomposition in the first 5 days. So that oxygen provided oxygen for the bacteria. So in the first 5 days, they were respiring aerobically, and then once the oxygen ran out, they went into anaerobic respiration. So we saw on the graph that this line of carbon dioxide started to drift down as anaerobic respiration kicked in because the oxygen was running out. Okay, so the carbon dioxide came from aerobic respiration. As soon as aerobic respiration stopped, the carbon dioxide level dropped, and it made the methane production much more efficient. Okay, so that was just a setup question, and I've seen that in an exam question. Okay, so continuous flow uses organic material, organic waste, to decompose it using bacteria in anaerobic conditions without oxygen, producing biogas, which is mainly methane, and the side product is slurry, which is used as fertiliser. So it's a very efficient process. There isn't any waste product from it because both of the products that are made can be used usefully. Hope you found that useful. Thank you.